Good morning, students. Good morning, very good morning. Wake up. Am I audible? Voice clear? Am I audible? Good morning, Saharan. Good morning, Manish. Ananya, very good morning to all. Okay, good. And board is also fine. Not too bright. I think today it is fine. Okay, yes, good morning, Sajid. Yes, good morning, Siri. Good morning, everyone. Wake up, wake up. Very good morning, Durga Prasad. Yeah, it's good, uncle. Arya, keep your actual name. What is uncle written here? Yeah, 140 is fine. You can try at your best. Yes, good morning, Preeti. Good morning, Farida. Very good morning, Shashank. Naveed, good morning. Good morning, Lavanya. Very good morning. I hope that you people are charged at home. In between, you are taking some breaks also, some snacks also. I think you are having. That's why quite charged. Yeah, you can get. See, paper was easy. You can get around 160 also possible. Yes, it is. But 140 is good. 140 is good. You can try. You can keep on trying. Okay, students. So, in the last lecture, we have discussed up to which part? We were discussing VSEPR model. Okay, in which we talk about the shape or geometry, which we have not discussed in the hybridization, because hybridization consider the total hybrid orbitals, which is electronic geometry. Which is electronic geometry that consider all the hybrid orbitals. But when we talk about shape or geometry, that means we are not considering lone pairs. We are considering the bond pairs. Okay, so we have discussed AB2, AB3, AB2L type bend shape, AB4, AB3L, AB2L2. Remember? Then I discussed about AB5 type. Array, yes or no? We have discussed about AB5 or not? We have discussed it. We have discussed AB5 in which it is belonging to which hybridization? sp3 dehybridization, but having two bond lengths. Why? Because two bond angles are there. One is 90, one is 120, which is adjacent angle. And generally we talk about always adjacent angles. We rarely talk about the 180 degree. But yes, total angle we can say yes, it is 180 also. When you read NCERT, it is giving adjacent angles everywhere. Okay, AB5 type में we have discussed the axial bond lengths are more than equatorial bond lengths. Remember how? Because at axial position it is getting three 90-degree bond pair repulsions, whereas equatorial is getting two 90-degree bond pair repulsions. So that is why, which is more repulsion position? Axial. That is why lone pairs, double bonds and bulky atoms, they should occupy more spacious position, which is equatorial position. याद आया कुछ? अरे भाई याद आ रहा है? That these points we have discussed. Yes, okay. Good. Okay, very good, very good. That point you remember because this is useful. VSEPR model is very useful. Yes, Kavita, good morning. Wake up fast. Come join us. So here the point is that AB5 may we have discussed the two bond lengths, axial and equatorial. Axial more, equatorial less. Then examples I have given. I said that you will try every example separately also in the practice notebook. Then we have discussed, I think, AB4L type also, which is seesaw shape. Discussed or not? Last was which geometry? AB6. Last geometry was AB5 only, or beyond it also discussed? ठीक है, last was AB5. ठीक है, what's the example we have discussed? Only examples written or some examples discussed also? Some examples discussed also. PCl5, any other example? Other examples also discussed, like XeO3F2. That is also discussed, yes. Yes, that time one example I have written wrong in which lone pairs were there. I have written one example XeOF4. That one student said it is not matching. Yeah. Yes. So any example you have a doubt among them? Among these examples, any questions you have? All the students who are attending, any questions you have in that part? Any example you are finding it difficult in writing? Mainly we are writing the structure, considering the valence electrons with the central atom, and then writing the bond pairs maximum. ठीक है, so हमने डिस्कस किया अप टू AB5 तक. Now today we will discuss AB4E or AB4L type. XeO3F2 Sela Kavita. ठीक है. So I am discussing that example again. XeO3 diagonal hybridization. Yes, Vijay. It means you are not reading the NCERT. Are you reading NCERT? Your whole focus will be that after class you will not miss any line or any page which is discussed in class from NCERT. Make this habit. If you do this, then see by exam time your confidence level also very high, and you will yourself say that I know everything of NCERT. That is also a big morale booster for you. So Vijay, if you see here, what is written? Getting it, Vijay? This type of hybridization is also known as, okay, every student, I am reminding you, see, my task is to give you the guidance that how to approach the NEET level questions and how to prepare. But ultimately the task has to be done by you. NCERT reading must. Make this habit. Do not think that only notes. Combo it is. Notes plus NCERT. NCERT in reading of paragraphs, reading of the examples, exercise questions. Then after that NCERT exemplar. So make this habit. I will not leave these things. And every chapter I will do completely. Every lecture I will read the portion completely. Underline important terms. Revise 10 to 15 times same day. Revise 5 to 7 times same day. As per your speed, you can do it. Every student, make this habit. These are the small things. These are just like bricks. You know, you can see the wall here. You are not able to see the wall, but here wall is there, in which we can say it's a wall, but it is composed of bricks. Similarly, the success of your selection is there, or your NEET 2024 wall is composed of the bricks of classes, lectures, your preparation. If you do it very well, your wall will be of NEET 2024 will be more colorful. You will be in the best college. So try every small effort which you can do. Reading, yes, it is possible for you. Every student, make this habit. I will read NCERT even if still I have read it 2-3 times. I'll still read those underlined points. You will realize with time that every question, even minute terms are given in the statement type. You will easily catch. That is the point. Okay, Vijay, getting it? You will read the NCERT again today from the hybridization, and today we are discussing VSCPR also. Which one? Today we are discussing AB5L type structure, sorry, AB4L, and before that one doubt was raised by a student, which is about XeO3F2. Now in this structure, the student who asked it, xenon has how many valence electrons? 8. Oxygen will form how many bonds? Neutral it is. It forms double bond with central atom. How many double bonds each oxygen is formed? 3 oxygen will form. They will form 6 bond totals, means 2 double bond each with oxygen. That is in this manner, suppose. Xenon 6 electrons shared. How many left out of 8? 2 electrons. Fluorine or halogen, they form a single bond and their octet will be completed. This is how it is written. XeO3F2 structure. So you have to count the valence electrons. Xenon 8, 6 electrons are used up with oxygen and 2 electrons with fluorine. It belongs to which type? AB5 type. Why? 1, 2, 3, 4, 5. Getting it, Kavita? So all examples make this habit. I will write after the class also. By using which part? Valence electrons. Then using these valence electrons in the bond formation with oxygen and fluorine. And how many left? These lone pairs will make it the other shape of the molecule. Although here no lone pair, so it is completely AB5 type. Now starting with the next type. Which one? AB4L type structure. AB4L type. AB4L type. It is derived from which regular geometry? AB5. Trigonal bipyramidal. ठीक है? Points you have written last class. Lone pair should occupy which position? It should occupy the equatorial position. So here any equatorial. Suppose a central atom A. Here it is equatorial position, and others are bond pairs. AB4L type structure. This is seesaw geometry or seesaw shape, or other name is also given, that is distorted tetrahedral. When you check the NCERT, AB4L, other names are also mentioned, all underline them also. Distorted tetrahedral, or other one is which one? Folded square. These are other names also given for which type? AB4L type structure. Okay. And here due to lone pairs, surely bond angle will be distorted. In trigonal bipyramidal, what are the mainly adjacent bond angles? 90 degree and 120. Here they cannot be 90 and 120 for sure. Why lone pairs are there? Due to lone pair bond pair repulsions, bond angle will be less than 90 and 120. Okay. Then which examples? Add the examples. One example given there. In AB4L type structure, examples I'm writing here. One is SF4, SeCl4, SF2Cl2, XeO2F2. Okay. These are the examples you can add in NCERT. SF4 given, SeCl4 possible. These all are which type? AB4L type structure, in which central atom has one lone pair and 4 bond pairs. Getting it? आई बात समझ में? Any example you want to write? Suppose SF4 I am writing here. Now firstly SF4 structure will be in this manner. Any side you can write. In this structure, SF4, how many sigma bonds? 4 and 1 lone pair. If I talk about hybridization, or if I talk about steric number, will be 4 plus 1, 5. Hybridization will be sp3d. ठीक है? Getting it? And lone pair will occupy which position? Equatorial. Any of the equatorial. Here, there, all are same. Similarly, you can try XeO2F2 type. Try the example of XeO2F2. Oxygen neutral overall, 2 double bonds with xenon. That means 4 electrons of xenon used. Fluorine will be 2 given plus 2, 4 plus 2, 6. And then 1 lone pair left on xenon, AB4, oxygen 2, fluorine 2. And 1 lone pair, AB4L type. So try to write the structure. Structure will be AB4L. The moment you get the idea, it is AB4L type. You firstly put lone pair on equatorial. I can put here also. No problem. Double bonds where? On equatorial. Remember this thing that last class you have written, lone pair, double bonds and bulky atoms. They should occupy which position? Equatorial position. Every student getting it? Any questions you want to ask? Any of the student here in this example? Any point you want to ask? Okay, very good. Now try. From AB5 regular geometry, we have discussed AB4L, 1 lone pair, 4 bond pair. Now next is 3 bond pair and 2 lone pair. Still summation is 5 now. That means it is derived from which electronic geometry? Trigonal bipyramidal. Okay, only difference is now VSEPR model is important here because we are discussing lone pairs along with bond pairs. So here AB3L2 type structure will be that 2 lone pairs on the equatorial position and other bond pairs will be available on the axial plus equatorial. So it is which one? It is T-shape. T-shape molecule. Any other name given for that? Example I'll write first. Examples are ClF3, ICl3, XeF3 plus, BrF3, XeOF2. These are the examples of AB3L2 type structure. In NCERT, I'm checking where it is given. AB3 T shape is only given, but example T shape only given, same given. Okay. Now bent shape also, bent T shape we can say. Now in NCERT you can underline that information which is given there. For SF4 they have given important information. On which page it is? On the page 116. On page 116 this is given. This you can underline that here clearly given A and B. All the students keep your NCERT with you. Underline this term here. It is more stable. Although logically also you have underlined earlier, written earlier, lone pair at equatorial. That is how, but still you underline, because question can be framed out of these four or out of these structures which is a more stable geometry. Answer will be this one. Reason given here that you can underline further. In A, what happened? Lone pair is present at axial position. So there are 3 lone pair bond pair repulsions at 90. Whereas in B, lone pair is at equatorial position. There are only 2 lone pair bond pair repulsions. Hence, arrangement B is more stable. And this different names given: distorted tetrahedron, a folded square, or seesaw. Underline kiya ye, it was for previous example. Next example, again here, different possibilities given. In A, lone pairs are at equatorial, so there is less lone pair bond pair repulsions as compared to others. So reason to already you have written earlier, but still you mark the example. ClF3, where lone pairs at equatorial is better as compared to which one? B and C. Underline kiya ye, better is A as compared to B and C. So structure A is most stable. Structure ClF3 given, so that firstly I will write ClF3 में 2 lone pairs at equatorial, then remaining fluorines here, and this is the T-shape structure of ClF3. This is a more stable geometry. It is more stable geometry as compared to other possibilities. Any other structure? XeOF2, try this one also. XeOF2, xenon 8 electrons, oxygen will form double bond. ठीक है, 2 इलेक्ट्रॉन खा गया किसके? xenon के. Xenon used 2 electrons with oxygen, 2 electrons used with fluorine. That means it is using 4 electrons in bonding, and remaining 4 electrons of xenon are which one? They converted into non-bonded electrons, which are lone pairs. So 2 lone pairs and 2 bond and 3 bond pairs, oxygen and 2 fluorine. So xenon will be 2 lone pairs, double bond oxygen, lone pair at equatorial, double bond at equatorial, and fluorine will be like this. XeOF2 structure. 6 plus 2, 8, yes. Getting it? So the remaining examples you can practice. You can add all the example in practice notebook line se. 30 examples, 40 written by this time. Try every example on your own, then check your answer. Next type is AB2L3 type structure. Next is which type? AB2L3 type structure, in which 3 lone pairs, they occupy equatorial, preferable for them, and bond pairs will be. So it is which shape or which geometry? Linear shape or linear geometry. AB2L3 type structure. AB2L3 type structure. Examples I'll give. One example is I3 minus, ICl2 minus, Br3 minus also possible, XCF2. These are some examples of AB2L3 type structure. Yes, Vijay, it will be shared in the groups also. Okay, it will be shared. Today is Monday, it will be shared in the groups, your test syllabus. But whatever we are doing today, it is also a part of test syllabus. which is hybridization and VSEP are combiningly. Now, in this case, I3 minus means central atom is iodine. Okay? Iodine has 7 valence electrons. Central atom iodine bonded to 2 other iodine by single bond. Halogen, firstly, they form only single bond. So it is giving out of 7 2 electrons in bond formation. How many left? 5 left. And minus 1 charge is also there. So you will consider 5 plus 1, 6 electrons left, which are 3 lone pairs. So iodine has 2 bond pair with other iodine and 3 lone pairs. It is a linear structure in this manner. And other are lone pairs of electrons at equatorial position. And net charge will be minus 1. If the question is hybridization of iodine in I3 minus, then you will say 2 bond pair and 3 lone pair. For hybridization, 2 bond pair and 3 lone pair, 5, therefore sp3 dehybridized. So electronic geometry will be trigonal, bipyramidal, shape or geometry will be linear. Getting in this example, try XeF2. Xenon examples, all I am writing, because generally xenon, the moment you see, sometimes you're getting doubt. That's why we are doing every example which is with xenon and others which are similar. Out of them, only one I write. Remaining you can try at your own, then you can ask me if you have a doubt in the next class. XeF2. With fluorine, 2 single bonds. How many electrons used? Out of 8, 2 electrons used. Then how many left? 6. 6 means 3 lone pair and 2 bond pair. So it is which type? AB2L3 type. So firstly you will remember it is AB2L3 type structure. 3 lone pairs at equatorial and 2 bond pairs. Hybridization of xenon will be how many bond pairs? 2 bond pair and 3 lone pair. Summation 5. It is sp3 dehybridized. Yes, it is linear. Then next is regular geometry. AB6. Central atom A, octahedral if you remember. Octahedral geometry in which 4 atoms or 4 bond pairs in same plane, one above the plane, other below the plane. It is octahedral. AB6. No, AB6 is that one, octahedral. Square planar will be derived from AB6 geometry. Here, bond angles 90 degree. All adjacent bond angles 90 degree. All bond lengths same or different? Tell. Here bond length same or different, just like trigonal bipyramidal. Every student think about it. In trigonal bipyramidal we have 2 bond lengths. So here in octahedral 2 bond lengths or okati bond length? Hari saying same, okay, Kavita same, Manish, Vijay same. Other students think about it. Channa same, Jyotsna same, Dame, okay, very good. So point is here how many adjacent bond angles? Only one. Therefore, one type of bond length. Getting it? In trigonal bipyramidal, we have 2 types of adjacent bond angles, and that is why we have how many types of bond lengths? Rundu type of bond length. Aayi baat samajh mein? So here, all bond angles 90 degree adjacent means same bond angles all, and all bond lengths same. If the question is how many bond angles, then we can say adjacent 90 degree and opposite will be 180 degree. opposite is, we can say opposite, but whenever nothing is mentioned, we take which one? Adjacent bond angles are deciding the properties of the molecule. ठीक है, examples. Example here, SF6, most common example it is, or SCl6. More examples I'll give. PCl6 minus. Other example is xenon with 6 oxygen and 4 minus. Other is XeO2F4. These all are the examples of which one? AB6 type. You can try any example. SF6, sulfur valence electrons, how many? 6. How many fluorine? 6. That means all 6 electrons in bond formation with 6 fluorine, AB6. That structure you can write because it is given in NCERT. Central atom sulfur with 4 fluorines in the same plane, one above the plane, other below the plane. That is the structure of SF6. These are in the plane with the sulfur, other is above the plane and below the plane. Now, if I ask you a question, if you remember, we have done in AB4 type that how many 109.5 degree bond angles. Now here tell how many 90 degree bond angles are there in octahedral. How many 90 degree bond angles are there in octahedral geometry? Durga Prasad responded. Okay, we'll see. Durga Prasad. Any other student? Srinu. Okay, let's see. Just like remember, tetrahedral we have done. How many tetrahedral? 109.5. Answer was 6. Okay, Kavita responded 12. Amina responded 12. Sajid responded 12. Very good. Konda responded 6. Okay, those two who are working, very good. Keep on working. Identify how many 90 degree bond angles are there in octahedral geometry. Vijay 12, very good. Kavita 12, Sela Kavita 6. Okay, we'll check it. Bhavya getting 8. Lachana 12, very good. Naveed 12. Correct answer is, what's the correct answer? Answer is 12. Those who are getting 12, even they have not responded, but they have written in their practice notebook. But very good, very good. Now see how. If you observe here, AB6. Each angle here in the plane, this is 90 degree. In the plane, all are 90. Then above the plane, fluorine or bond is there. It is also 90 degree with respect to all the 4 fluorines here in the plane. Below also perpendicular, it is also 90 degree with the all the fluorines in the same plane. So if you observe, with respect to this atom, how many 90 degree? 4. With respect to this atom below the plane, how many 90 degree? 4. And with respect to each other, these all are which angles? They all are 90 degree with respect to each other. So 4 above, 4 in the plane and 4 below, total 8. How many? Sorry, total 12. How many 90 degree bond angles are there in octahedral geometry? Sometimes these questions can be framed. And these are not difficult questions, just you have to quickly imagine the structure in front of you. Octahedral, this one, 4 perpendicular, 4 below. And in the plane, square planar, it is also all making 90 degree with respect to each other. आई बात समझ में? So any other structure you want, I should write or you will try after the class. Among them, which structure you want that I will write or you will try at your own end, then you will ask. SCl6, array are SCl6 just like brother of which one? SF6. How? Central atom A, which is sulfur. Attached atoms Cl, how many? 6. AB6. So firstly you put sulfur here. Other are Cl, how many? 6 Cl. So once you find the structure which type, put the atom as it is. A will be S, and all B atom Cl. ठीक है, Akhil getting it? Bhavya and Naveed saying XCO6 4 minus. Now see, Bhavya and Naveed, xenon is there and oxygens are there, but overall charge 4 minus. Remember, when minus charge is there, oxygen will have the minus charge. 4 minus means out of 6 oxygens, 4 oxygens are with minus charge. 4 oxygen with minus charge, remaining 2 are neutral. Then total summation 6 oxygen. So you will remember, or you will put like this: xenon, 2 doubly bonded oxygens and 4 singly bonded oxygens. 2 doubly bonded oxygens and 4 singly bonded oxygens, net charge -4, like this one. All students write down this example: XCO64 minus. Xenon. I will firstly put lone pairs or double bonds which are 2 given opposite. Why? Repulsion will be minimum, so I will put them here. 2 oxygens here. Double bond, maximum distance. Then remaining I will put here O minus here, O minus there, O minus there, O minus there. You can also put 2 double bond here and there. Condition is not they are above and below. Condition is 2 double bonds should be opposite with respect to each other at 180 degree. So you can write here one important point also. Two double bonds at which angle? 180 degree, or 2 lone pairs at 180 degree. Or if one lone pair, one double bond coming, they also create more repulsion, so they should also be at 180 degree. So combiningly you can mention, may be useful for other types. And reason is what? Same reason, to avoid the repulsion factor, we can put them at maximum distance, which is maximum bond angle 180 degree. In this case, Preeti, if you remember, in octahedral we have not discussed about any axial or equatorial. Okay, so all bond lengths are same. So here no use of equatorial or axial term. All bond lengths same. You can put them anywhere, only keeping the point both should be opposite with respect to each other, which may be like this, which may be like this, which may be like this. Getting it, Preeti? ठीक है, other examples you can try. I want that other example you can try. In next class I ask na, whenever you have a doubt, at the beginning keep your doubts ready. This example I have a doubt, I'll give you hint or I'll write the structure. Getting it, everyone? And it is most important part going on of this chapter. Apart from the MOT which we will do, hybridization, VSEPR, very important. Every example you can try both with both, writing the structure as per VSEPR, finding the hybridization. So now talking about the other examples written, yes. XeO2F4, you will try this one, AB6 type. Next from the AB6 type, what is derived? AB5L, 5 plus 1 still 6. That is one lone pair. Now tell me, when all bond lengths are same, we can put one lone pair on any bond because there is no axial and equatorial. So one lone pair can be at any position. Central atom A, I can put anywhere, so I can write it like this. and one lone pair like this. So AB5L type, it is square pyramidal geometry. AB5L type square pyramidal geometry. Examples are ClF5, IF5 structure, xenon F5 with +1, BrF5, XeO F4, AB5L type, yes. These are the examples of AB5L type, which is square pyramidal. And here also bond angles will be somewhat distorted by one lone pair is there. And if you talk about hybridization of this type, it is 5 + 1, 6. So it is also just like octahedral, it is sp3d2 hybridized. So here, example of ClF5. Firstly, ClF5 example. In chlorine outermost, how many electrons? 7. Out of 7, 5 participated with fluorine. So how many electrons left? 2. That means one lone pair. 5 bond pair, one lone pair. AB5L type. On any bond, I can write put the lone pair. Here you can write, here, anywhere you can put. All are identical because one lone pair can be at any position. But if two lone pairs are there, they should occupy exactly opposite position. That makes it 180 degree. And here this point is not applicable. So this is ClF5. Other one is which one? XeF5 plus. Try this example. XeF5 plus, which is xenon. How many electrons? 8. 5 in bond formation. How many left? 3. +1 charge means you will reduce out of 3, 1 less. That means 2 electrons left, 1 lone pair. So 5 bond pair and 1 lone pair. Right, on the structure of XeF5, it is AB5L type. Anywhere you can write the lone pair. Here also I can write, you can write anywhere. All are same positions. No axial, no equatorial. Net charge outside +1. XeF5 plus hybridization of xenon will be 5 sigma bonds, 1 lone pair, 6 sp3d2 hybridized. So if this example, you can reframe as per your convenience all the examples, find out their hybridization also. Till this point, clear? Any doubts up to this example? AB5L type, because next we are discussing AB4L2. Up to this part. Whatever remaining examples written, you will try them. You will again try them as per which type? AB5L type. Okay. Next is AB4L2. How many bond pairs? 4. How many lone pairs? 2. Lone pairs 2. Where they should be at? At any position, or they should be at particular orientation? AB4L2, 4 bond pairs and 2 lone pairs. Tell. They should be, yes, very good. Sajid responded, Kavita responded, Mulasa 180. Yes, very good. That's the point. That whenever 2 lone pairs are there in octahedral, you will put them at 180 degree. Anywhere, but they should be at 180 degree. Clear? If 2 double bonds will come in some example, like in AB6 we have done, they should also be at 180 degree, best geometry. So now, keeping this in mind, central atom A. 4 bond pairs, writing them all in the same plane with A, and this is AB4. How many lone pairs? 2. One above the plane written, one below the plane. So electronic geometry will be what? Electronic geometry will be octahedral, but shape or geometry will be square planar. As per VSCPR model, it is square planar, which is AB4L2 type structure. Remember, it is not like DSP2 example. Remember, DSP2 is different. Wherever d orbitals are coming, that is different because of coordination compound. It is square planar because of it is 2 lone pairs and 4 bond pairs. ठीक है? Yes, example is XCF4. More examples I'll give. One is XCF4. Other example is ICL4 minus. These two examples are there. If you have any other example, you can add. These examples are related to AB4L2 type structure. Xenon, 4 electrons with fluorine and 4 electrons left means 2 lone pairs. So xenon with 4 fluorines in this manner and 2 lone pairs like this square planar geometry. Square planar shape or square planar geometry, but electronic geometry will be octahedral. ICl4 minus, same case, central atom iodine, 4 electrons with Cl minus 1 charge means how many electrons left? 4. So ICl4, firstly Cl atoms in the plane, square planar, and 2 lone pairs in this manner. And net charge you can say minus 1. So these are the different types, in which case in the AB6, AB6 regular, AB5L, this is square pyramidal, and AB4L2, it is square planar. Below it is not given because lone pair more means more repulsion, so you will not get beyond AB4L2 type. So up to this it is important for us. After AB6 that is not important, which is AB7. Even in hybridization I told you that hybridization example also not given there. So AB7 is pentagonal bipyramidal, same like hybridization we have done, same example. 5 bond pairs in the same plane. One above the plane, other below the plane. It is pentagonal bipyramidal. PBP. Bond angles कितने थे भाई? Bond angles 90 and 72 degree, which are in same plane. 5 bonds, they are 72, and adjacent angles, one above the plane, other below the plane. Yes, hybridization sp3d3, very good. Example will be IF7. ठीक है, less important pentagonal bipyramidal as usual, but for the information, even in AB7 there exists AB6L type, but again that is less useful. So we are not focusing on further types of AB7, which is AB6L also there, AB5L2 also there, which is because it is nowhere mentioned. ठीक है, done. So this is the part of the VSCPR model in which repulsion factors are considered. Then we have discussed geometries in all the types. Some are electronic geometry, some are regular geometries along with the distorted geometries. Bolo. This is about the VSEPR model. Now tell any point up to these models. Any student, any point you want to ask up to this point, up to the types. Any one of you. After the class, you will complete this portion of reading. Which one? Already partially, though you have read it. It is from which page number you will read again? The main postulates. From this page number you can. 113. All the lines you will still read. 114, 115, 116, and it is 117. Because VBT already we have discussed, so I am not mentioning VBT to again read today. You will read up to this example, which is useful for which concept? VSEPR model. Page number 1132, 118, 117. ठीक है, that part reading. In the notes, example you will write again and try them. Merge with hybridization examples. Then, now after this VCPR completion, I will give you that set of the examples so that you can write the. Now you will find the structures and hybridization. ठीक है? You will try these questions. Some are already completed, but still for practice you can write. I'm writing the questions. You will try those examples. You will try those examples combiningly. You'll write the structures as well as you find the hybridization. You will try these questions at the end. After learning from the notes, all the examples done, theoretical part covered, then you will try these examples randomly, they are given. For practicing, it is good. ठीक है, I'm shifting the slide slightly towards the right side. Only write down the questions right now. Sixth one is SCl6. It is only 6 written. It is SCl6. Sixth one, all students write it. It is SCl6. Only write the question right now. You can try them separately after the class. SCl6 repeated, you can remove them. If it is repeated, now you can remove them. 12th one is repeated, okay. SCl6 repeated, you cannot write it, now you can leave this one. Other one you are saying which one? XCF4 also repeated, okay, fine. That also, this is repeated. These two repeated, any other repeated? 2 times written, XCF4, yes. So you cannot write that one, 12th and 14th. ठीक है, these are some examples written which we can try after the lecture. ठीक है, almost several examples already we have discussed, है ना? Some are new, maybe not written, so that those examples you can write and we will discuss in the class. Whichever you have a doubt, you have to tell me in the next class. I'll write that one because I will not be able to recall all this again. Getting it? So these examples will be, I think, more than sufficient for you to practice the example by writing the structure and also finding the hybridization. Maximum examples covered, maximum. Somewhere you have to know the structure also, somewhere, but that I will discuss, no problem. Okay, students? So that is the class which is completion of VSCPR and hybridization together. Next class, I'll discuss those questions. In class we will discuss, Srinivas, in next class we will discuss these examples, NO2 plus some structures, as I said, I have to write them. Top part not visible, okay, I'll write this one, it is now it is fine. Okay, students. That part we have not discussed about the bond angles. We have completed the main theoretical part with examples. Now bond angle we will use the term that how it will be affected by the electronegativity. It is visible here. It is only 29th example. It is visible now. Maybe in your screen you have not clicked. Maybe it is top part is visible. Everyone. Now fine. Vijay. ठीक है. Okay, students, take good care of yourself. We'll meet in the next class. See you soon. Bye.